All right, so in environmental science, unit one, we are actually going to go to module three, which is in fact natural resource use. All right. All right, so let's begin quickly with module three, question number 5A. For any named Caribbean country, identify two of its natural resources for 3 marks. Now, folks, I would like to focus on Guyana. So the named Caribbean country is in fact Guyana. Two of its natural resources can simply be forests. All right, Ghana is actually known for its forests and also for gold. All right, gold is in fact mined in Guyana. All right. Now, part B gave 4 reasons why one of the natural resources you identified in A above is important to the named Caribbean country. Now, let us focus on gold. All right. Now, first and foremost, we have to understand the first point is that gold can be used after the processing phase. It can be used and formatted properly and shaped, right, to create jewelry, right, which can simply be sold on a domestic level or even on a regional, international level. Secondly, gold can actually add to the GDP of a country because this particular natural resource can in fact be exploited and utilized, right, for an economic purpose, which adds to the GDP of a particular country. Thirdly, those persons who are in fact involved in the mining processes or even the processing phases of gold, all right, we have to understand it adds some level of employability. All right, employment opportunities are in fact granted to those persons who are actively involved. Last but not least, I would like to highlight the fourth point. We have to understand that it is in fact used, gold can actually be used as a form of collateral for many economic transactions, right? Some people may even decide to trade, all right, on a very local level or even on a wider scope. They may decide to simply trade, right, utilizing gold as a form of currency, right, in some localized conditions, all right. Yeah, so let's go through quickly part C, all right, as we move down here. Large areas of country X are covered in dense forest. In 1975, there was a little road access to many of the forested areas and no governmental regulation, all right, of illegal log removal in remote areas of the country. During the period of 1975 to 1995, that's actually a 20-year period, two important events occurred in country X, sorry, that affected the illegal tree harvesting trade. Now, first and foremost, there was a new road built, all right, in the interior of the forested areas by the government. And secondly, there was a new environmental policy regulating tree harvesting was put in place. Now, figure 6 below illustrates the trend in illegal tree harvesting in country X from 1975 to 1995. Now, folks, I want you to pay very close attention to this particular graph. All right. As you can see, this is a particular line graph which highlights the patterns or the trends associated with illegal tree harvesting associated. So we know for sure, all right, we can see variability, differences in steepness and topography lines. So look at this for basically 1 minute. Now, the first part of the question, in what year was the new road built? Now, folks, going back into the actual question itself, two things happened in this particular country. First and foremost, a new road was built, and secondly, a new environmental policy to regulate tree harvesting was put in place. Now, the illegal tree harvesting can actually be contributed or influenced or promoted by the development of a road because that provides accessibility. And that would actually be attributed to a very significant spike, all right, in terms of illegal tree harvesting trade. So that will typically be associated with this particular region here. Roughly, all right, we have 75, 76, 77, 78. You can see approximately in the year 1978, all right, the road was actually constructed. All right, now part two, explain, all right, how the new road might have affected the illegal tree harvesting trade. Out of 3 marks, class, what would the road do? The road itself would in fact act as a form of access or provide some level of accessibility that will actually contribute positively to the illegal tree harvesting trade because these illegal loggers will simply have an access route simply into the forest where they can expeditiously, right, remove the forest cover and simply have a transport route associated with that fact. Now, thirdly, explain how the new environmental policy would have affected the illegal tree harvesting trade. Now, folks, going back into the graph, in terms of the new environmental policy regulating tree harvesting trade, you have to understand that will actually reduced to a very significant extent the illegal tree harvesting. All right. And that is typically associated with this particular region here, which is roughly in the year 1980. All right. Use a ruler for the exam, right? This is roughly in the year 1980 if you look at it. Because beyond 1980, you saw a decline, right, in terms of the illegal tree harvesting trade. To answer the question quickly for part 3, all right, the new environmental policy would have actually had a negative effect upon the illegal tree harvesting trade, thus contributing to a decline, all right, in the process itself. Now, part 4. How long did it take for the illegal tree harvesting trade to return to the level that existed before the new road was built? All right, let's see. Now, folks, prior to the year 1978, which is here, this was the original period of time before the actual road was built, from 1975 to 1978. The road was built in 1978. Now, they will ask you how many years, all right, where the illegal tree harvesting trade would have actually reached levels, all right, before the actual road was built. We know for sure the road was in fact built in the year 1978. So let's go through quickly. These levels in the year roughly in the year 1990, was in fact associated with, well, roughly a more stabilized or lower illegal tree harvesting associated. So that will be associated with a range from 1978 all the way down to the year 1990. Students, from 1978 to the year 1990 is in fact 12 years. All right. If you could do the maths, 1990 minus 1978, you'll be given 12 years. Okay, so keep that in mind for me, please. All right, moving in quickly. Give one reason, question 6A, give one reason why natural resources should in fact be conserved. Now, focus, students, we must understand that natural resources should be conserved primarily because many of them are in fact non-renewable resources, which means they can be used up. They can be used up, sorry, my bad. All right, and this significantly highlights the point that once they are used up, they can essentially be lost for a very long period of time. So non-renewable resources can fall within the category of natural resources, which can of course be consumed, right, if our practices are in fact unsustainable or not conservative. Now, part B, waste reduction and minimization has been identified as one method by which natural resources can be conserved. Explain this practice, how this practice can result in natural resource conservation. All right, first and foremost, let us understand that waste minimization and reduction is in fact a very conservative and sustainable approach. To actually answer the question, how is this practice can actually result in natural resource conservation, we must bear in mind waste minimization and reduction can contribute to less energy being required to treat, obviously with less waste, right? And less land space would actually have to be cleared, all right, for storage, especially if we are referring to landfill sites. Okay, if we have minimal clearance of the land, that means we have minimal forest destruction, and also at the same time, if we are requiring less energy, right, involved in the movement and the transference or even the compaction or even the treatment of wastes, we have to understand that that is in fact associated with a conservative approach where less energy or perhaps fossil fuels in this regard will in fact be utilized. Now, part C. Many industries require encouragement to practice waste reduction and minimization. See part 1. Name 2 measures that can be used to encourage industries to practice waste reduction and minimization. All right. Now, in terms of the 2 measures to basically encourage industries to practice waste, first and foremost, in many instances, the governments can actually facilitate or perhaps offer what we call tax break incentives. All right. Secondly, they can in fact be the implementation as well as the enforcement of proper waste disposal legislation. If they are in fact breached, right, can have an economic consequence or perhaps economic consequences or even be regarded as offense. All right, if they are in fact breached, of course. Now, explain part 2 now, see part 2, explain how one of these measures functions, all right, to persuade industries to practice waste minimization and waste reduction. Now, I'm going to talk about both of them for a minute, right? Tax break incentives, in terms of they having a functioning effect, in terms of persuading industries, we must understand. Every single industry is in fact associated or gravitate, right, towards some level of conservation, right, where they are in fact trying to minimize expenses. So they are trying to reduce their economic expenditure. All right. In doing so, tax break incentives can actually aid in terms of persuading industries because there will be, in fact, be minimal amounts of money being spent, all right, on waste reduction, minimization, also remediation cost, all right, in terms of treating with waste and stuff like that. The second point, where we refer to the implementation and the enforcement of proper waste disposal legislation, we have to understand enforcement is a major thing. There can in fact be law, but enforcement is in fact something which is very important. And in terms as a one of the pillars for enforcement, we have to understand that if there are in fact consequences, if the law or the legislative measures in fact breached, right? If the legislative measures are breached, we have to understand that there can in fact be economic consequences. What do I mean by that? You can actually be charged. You might even be forced to pay what you call economic penalty, all right, a ticket or whatever the case may be. All right, so this is in fact something very, very important. Now, part 3, discuss one action that would contribute to the effective use of these measures in the curriculum. All right, that particular action would in fact be associated with the establishment of what we call an independent body, right, to monitor and also to account for the waste disposal on a frequent or on a regular basis. And why is this important? Because the lack of prejudice or the lack of favoritism or the lack of bias, right, can actually go a very long way in terms of fostering a cultural change, all right, which can be very significant in terms of the moving forward in the direction of sustainability. Okay, let's go through quickly. We have part D. The extraction of gravel in quarrying activities can result in significant water pollution due to sedimentation and siltation. Now, folks, sedimentation and siltation is the accumulation of particulates, all right, in the waterways and stuff like that. To combat this, a series of settling ponds are used to reduce its total suspended solid load leaving the quarry. Now, figure 7 illustrates the water quality of the quarry effluent before and after, all right, each of 4 settling ponds. All right, everybody, take approximately 1 minute, all right, and look at the particular image on the screen, the graph. I want you to be sure to use your ruler, and you can actually determine the values, right, for before the settling ponds and also after settling pond 1, 2, 3, and 4 coming down. So take that particular 1 minute for me right now. Now, part 1, what is the percentage reduction of total suspended solids in the quarry effluent for the entire treatment process? All right, so before the settling point, if we use our ruler, we will see it was actually 430 milligrams per liter. And after the settling point 4, we actually came down to 30 milligrams per liter. So 430 minus 30 milligrams per liter all over the original value of 430 multiplied by 100/1. I'll show you what that looks like. The calculation will actually tantamount to an approximately 93% reduction. That is a very significant reduction. Huh? All right, so part 2. What is the percentage reduction of total suspended solids in the quarry effluent after 2 ponds? Let's go through quickly. Be sure to use your rulers for me, please. So the original value was before the settling point was 430 milligrams per liter. And after, well, the second settling point, we actually came down to 40, all right, milligrams per liter. So let's calculate that quickly. Observe the calculation on the screen. You can actually see it is approximately 90.697, which is roughly 91%. So the answer for part 2, right, is in fact roughly 91%, approximately 91%. Part 3, 4 settling points necessary for good pollution control in this quarry. Give one reason for your answer. Now, folks, look carefully. After 2 settling points, we had 91% sediments accumulating, right? And after you had 93%. Now, this is an increase by 2%, right, from these 2 settling ponds, right? For using and what we call an ELAP principle, right, as low as reasonably practicable. All right, that means you can reduce the amounts of components or total suspended solids as low as reasonably possible. All right, if you follow that approach, you can actually be minimizing, all right, to the least. Sorry, I should say to the most. All right, in terms of the amounts of components that can actually be washed out into the waterways. All right. All right, students. So we are in fact in 2012, Unit 1, Paper 2. Let us begin with Module 3. All right, so number 5 here, Module 3, number 5, Figure 3 shows variations in tree density, all right, from 1980 to the year 2000, which is in fact 20 years, in 3 Caribbean countries. Study Figure 5 and answer your questions that follow. All right, so let us look at the image here, the figure, all right, the graph really. We are seeing here, this is in fact, the bold line is in fact country A. The long dashes are in fact country B, and the small little dots, I should say small dashes really, basically fall under that of country C. All right, we have a 20-year period, right, which is from 1980 all the way down to the year 2000. Let's go through quickly. All right, so the first question basically identify the country A, B, and C that practices consumptive use of trees. Now, look at the graph again. Take a minute and look at the graph. Any area that utilizes consumptive use of any resource, you will have a decline in that particular resource. From the y-axis, we are seeing this particular line is actually moving downwards in comparison to all the others. So I would say country B, right, is associated with consumptive use of trees. Part 2 basically asks us, indicate a reason for your answer. Now for 2 marks, very quickly, we know for sure from the graph, country B was the only line that was associated with a decline, all right, which is typically associated with a decline in tree cover, all right, for that particular tree density within a 20-year period. Now, part 3, in what year did the country you identified in A1, all right, begin to practice consumptive use? Now, at this point, you have to utilize your ruler, right? A long ruler preferably, or a straight edge of a page. All right, look at country B here. This line is country B. The point where it starts to decline, all right, that is in fact associated with the year where consumptive use was in fact practiced, and that will be associated with this particular time period, which is the year 1984. All right, so this is 80, 81, 82, 83, 84. So in the year 1984, consumptive use was practiced by country B. All right, part 4. All right, during the decade of 1985 to 1995, what rate of change of tree density was observed in the country identified at A1? Now we are talking about country B. All right, within that 10-year period, this a decade is 10 years, right? The rate of change. Let's go through that very quickly. All right, so let us use our ruler. All right, use a ruler or a straight edge of a page. All right, for the year 1985, if you go all the way up, you'll realize it will be somewhere across here. All right, I'll go straight across. All right, on the y-axis, you will realize it will be roughly at 2,900 trees per square kilometer. All right, so just keep that in mind for me. 2,900, right? Now, for the year 1995, which is here, 1995 will roughly, if you use your ruler, you go straight up, it'll be roughly there. When you use a straight line distance now from that particular junction, you go straight across into your y-axis, it will be roughly at, I am seeing 1,200. All right, so we have 1985 value is in fact 2,900, whereas 1995 value is in fact 1,200. All right, keep that in mind for me. Now that being said, all right, if you were to check it over again, all right, I always advise that you check it over, all right? Don't just utilize my word for it, because sometimes using something on the screen and sometimes actually utilizing a value within physical paper might have a slight variation. So always check that back for me, please. All right, I just double checked it. I realized it actually coincides with 1,200. So within a 10-year period, if you were to say 29 minus 12 divided by 10, let's go through that calculation quickly. All right, from the information that we have here, we said 2,900 was in fact the value for the year 1985, and 1,200 was in fact the value for the year 1995. So 29 minus 1,200, all right, as you can see here, that region there, all over a period of 10 years. So 2,900 minus 1,200 over 10 will actually give you 1,700 divided by 10, which is in fact 170 trees per square kilometer, because that's the unit here, all right, for the numerator, per year. So every year, there's an estimated 170 trees per square kilometer being removed. All right, being consumed. Okay. All right. Now, part five. Which country demonstrated the least change in tree density? Now, from the graph here, we can automatically see that is in fact this particular line. This solid line belongs to that of country A. For 1 mark, the answer would be country A. Now, question B, part 1. Other than logging, list 3 examples of consumptive use of natural resources. All right, consumptive use of natural resources. So apart from logging, we can actually engage upon fishing. All right, we could actually engage upon hunting. All right. We also have mining or quarrying or excavation. All right, so we have those 3 there. Now, part 2. A country wishes to invest in tourism as in non-consumptive use of their beautiful beaches. Several large hotels are planned for one of the country's best beaches. Okay, explain 3 possible environmental impacts of this proposed developmental area on the area. Sorry. All right, so they want to construct a large hotel. That is the objective, the plan for that particular country. Right now, construction, especially in close proximity to the coast, can result in number 1. There can, in fact, be an issue as it relates to sedimentation because construction dust, right, can simply find its way from the building area further outwards towards the coast and may also compromise the greater marine environment. These construction dust can contribute to sedimentation, which is in fact the settling effect of large quantities of fine or unconsolidated materials. All right. That can have a great impact upon the environment. Now, secondly, we have to understand that the turbidity of the water will be compromised. If you actually have sedimentation taking place, the actual turbidity of the water or the amount of suspended particulates in the water would in fact be very high. And the turbidity, as a matter of fact, would also be very high, which would affect the quality of the water because the quality of the water would in fact be poorer, right? Primarily because of the clarity being affected. Turbidity refers to suspended materials, and if that happens, that means the water would not be in fact be as clear or pristine as it previously was. All right, and that's 2. 3. We have to understand that these particulates and contains nutrients or even minerals which can actually offset or induce the productivity of algae. It can actually offset the productivity of corals or seagrass beds. What happens is that these added components can simply contribute to eutrophication, where algal blooms can actually be apparent, which means that algae tends to maximize upon the nutrient or the mineral content from these particulates, and they tend to flourish and they tend to outcompete existing corals which may exist in the periphery. And in doing so, class, even the seagrass beds are also competed, and this can result in a biodiversity decline. All right, so keep that in mind for me. Part 3. We have here to encourage natural resource conservation. The country in B2 above implements the following measures and tools for conservation. Now we have sustainable yield management, the use of substitutes for renewable resources, and also 3, the reduction and minimization of waste. Now, which one of the 3 measures listed above would apply to the proposed development in the country in B2? Now, class, we are talking about the development of a potential hotel or whatever the case may be here. And in reality, we must bear in mind that that would in fact be associated not with yield management. Yield management has to do with agriculture, so 1 is wrong. Number 2, the use of renewable sources of energy that is associated with industrial activities. The only answer that would be applicable would in fact be the reduction and minimization of waste. All right, so keep that in mind for me, please. The answer will be number 3, reduction and minimization of waste. Part 4, explain why the other measures would not apply to the proposed development in the country. Now, first and foremost, sustainable yield management would not apply to that hotel development, because sustainable yield management is associated with agricultural activities where conservative approaches are associated with minimizing the amount of erosion and also nutrient losses from the ground. That has nothing to do with hotel development. Secondly, The use of substitutes for renewable forms of energy. This is associated with combustion of materials or the utilization of energy source. All right, which in fact does not produce greenhouse gas emissions. That is for industrial activities. What we are talking about here is for tourism. We are not going to establish any industry. We are not going to engage in any form of agriculture. So that is the reason why number one and number two is in fact not applicable, all right, for the proposed development. All right. Now, question 6 is using only the examples of natural resources provided below. Copy and complete table 3 by inserting 2 renewable and 2 non-renewable natural resources. The table 3 is actually at the bottom here. But for the purpose of understanding, I'm going to go through all of them. We are going to categorize all of them as it relates to renewable and also non-renewable resources. Students, bear in mind for me, renewable resources under our understanding of it now, taking into consideration inexhaustible and exhaustible context. All right, terminologies. We must bear in mind that renewable resources are those which can be replenished, influenced even by our management initiatives. Non-renewable resources have an extremely low replenishment rate, and as a result, they can in fact be depleted from a natural environment given consumptive use of resources. So, groundwater is actually considered to be renewable, primarily because if we maintain the watersheds and also the vegetative cover, we can ensure that infiltration as well as percolation capacities can influence the amount of groundwater in the subsurface sections. So they are said to be renewable. Bauxite is considered to be non-renewable because once it is in fact used up, it's gone. All right. Seagrass beds, we can employ management initiatives to ensure the continuity of seagrass beds. So seagrass beds are said to be renewable. Sand is said to be non-renewable, despite the fact that there is a large quantity which exists naturally in the environment. Our level of consumption can in fact deplete it to a very significant extent. Oil is considered to be non-renewable, which is obvious. Gravel is considered to be non-renewable. Beaches are said to be renewable because we can employ management strategies to ensure its continuity and its the processes are in place to ensure that beaches are in fact not compromised or fully removed, all right, or eroded. Coral reefs are said to be renewable because in many initiatives in recent time we have seen where in Japan they have actually inculcated certain techniques to allow corals to be quote unquote planted, right, in certain parts of the seabed. All right, there's in fact a very massive project on the way right now. This has been going on for years. So they can in fact be managed. Gold is said to be non-renewable because once it is exploited and extracted in very large quantities, it will take a significant period of time for it to be replenished. Soils are said to be renewable because we can employ management strategies as well. All right, so I hope this was actually understandable. All right, so the first part of this particular question, we categorized renewable and non-renewable resources, all of them based upon the list that we had there. Now, part 2, discuss the effect of geographical and technological factors on the use of natural resources. Use suitable examples to illustrate your response for 6 marks. When we are talking about geographical factors, we must consider the aspect of location. Every single location on the surface of this particular planet is varies at some point. Well, yeah. All right, so keep that in mind for me. It can vary in terms of topography, latitude and location. Even the climatic condition will also be different, right, depending upon the locality of particular resources and where they are in fact situated in different parts of the world. Now, geographical factors can influence the level of extraction, the degree of extraction. The geographical factors, as mentioned earlier, can also be applicable in determining what challenges can in fact be met in terms of the extraction as well as the quantity of resources that can be derived from these localized areas. For example, oil and gas can be derived from very few areas. When I say very few, but from few areas, they are said to be localized. They are not ubiquitous. All right, even technological factors can in fact be a major issue, especially technological factors determining the extent or the machinery involved in terms of extraction and the processing phases associated with said resources. All right, if the technology is not efficient, then that means the level of extraction would not be up to par, or it would not in fact be efficient as well. And you can actually incur certain losses. But with the progression of time, technology improves. All right. For instance, mining and excavation and even quarrying of certain resources like aggregate and whatnot have in fact become much more pronounced and much more efficient with the progression of time. Even oil and gas extraction is in fact much more pronounced today than yesteryear. All right, so part B now. Table 4 shows data on the growth in population and gravel extraction activities in the country from 1900 to the year 2000. All right. There's a lot of years to be honest. Study the data and answer the questions that follow. Let's go down to the data set. Take approximately 1 minute. All right. I want you to look carefully in terms of what is actually being asked. All right. Look at years. All right, from 1900 all the way down to the year 2000. That is 100 years. All right. Population in millions, gravel extraction, thousands of tons. Remember, when you're putting anything which as it relates to gravel extraction, if you have to put a numerical value, make sure you put the thousands of tons. If you don't have that, you will get it wrong. All right, quickly, describe the pattern of population growth and gravel extraction in the period of the year 1900 to the year 2000. All right, so we have here what we can observe is that population increased progressively from the year 1900s all the way down to the year 2000. The same thing was in fact associated with gravel extraction from the year 1900 to the year 2000. So what we can say is that both the population and gravel extraction increased progressively with time from the year 1900 all the way down to the year 2000. So there is in fact a direct positive correlation, right, between both parameters, population and gravel extraction. Okay, moving quickly. Explain the relationship between population growth and gravel extraction illustrated in table 4. All right, we just mentioned here, we didn't realize this was a question, right? But we just mentioned that there is in fact a positive as well as a direct correlation between population growth and gravel extraction because both of them were associated with significant increases progressively with time. Now estimate, part 3, the amount of gravel that would be extracted in the year 2000. All right, sorry, 2020, my bad. It is an estimation. So what we can do, we can simply look at the table here. All right, we have to employ a bit of mathematical skills. All right, look at the table carefully. All right, so that's gonna show you something very quickly. I want you to pay very close attention to this. Break out your calculator if you have to. From 1940, that's gonna show you something. 1940 to the year 1960. All right, that was a leap or an increase by 0.8. All right, obviously we're talking about thousands of gravel extraction, right? Thousands of tons. From 1960, which is from 1.66, it went up by 1.2, right? Which is in fact 2.86 in the year 1980. All right, so that increase was 1.2 thousand tons. All right, from 1980 to the year 2000, it went up by roughly 1.17 to the year 2000. So 4.03 minus 2.86, which is 1.17. Now, students, 1.17 is approximately 1.2. All right, but let us assume that most immediate value. If you were to talk about the year 2020, which is the next 20 years from now, we could simply say 1.17 plus 4.03. All right, and you will actually get an estimated 5.2. So in the year 2020, it should be estimated to be 5.2. All right, the amount of gravel that will be extracted in the year 2020 will roughly be around 5.2 the units on top here, thousands of tons. All right, put that in brackets for me as well. Okay, so just based upon the most recent trends. All right, if you want to use the from 1990 to the year 2000 as the most immediate trend, you could utilize that. There's not a problem at all. All right, keep that in mind for me. So 1.17 plus 4.03 would in fact be 5.2. How do we get 1.17? We take 4.03 minus 2.86 to get 1.17, which is roughly 1.2, but we utilize the same 1.17 value. So when we add it here, we get in the year 2020 it should be 1.17 plus 4.03, which is approximately 5.2. All right, so I hope that's clear. Break out a calculator when you're doing something like that. All right. Now, gravel extraction can have a significant impact on the environment. So just two ways in which these impacts can be mitigated. Now, at the quarry sites, at the actual quarry sites, right, what we can have settling ponds, right? These settling ponds can reduce the amount of particulate matter or dust that is simply present in the water, which can contribute to turbidity. So settling ponds can be established in the quarry area to reduce the amount of particulates from being airborne or further suspended into outer areas. That is one. Secondly, all right, another problem with respect to air pollution and disposal, there can be significant barriers. All right, these barriers can involve the cultivation or planting of trees in the periphery of the quarry zone. All right, even after quarrying mechanisms have in fact been significant. All right, gravel extraction is in fact associated with the removal of vegetative cover, and in doing so, all right, there can in fact be the re-establishment or the reforestation of particular vegetation types simply to suppress the amount of dust or particulates from one given environment. And in doing so, it can actually help to provide that level of cover, right, which can also reduce the amount further erosion on the quarried environments. All right. Okay. So this is in fact the last question for 2012 paper. Let us continue with 2013 paper, Unit 1, Paper 2, Module 3. All right, so Module 3, Question 5a, the policies of a country's government can significantly affect the use of natural resources by citizens. One such policy is use of tax incentives. In 1978, country implemented a policy that allowed 100% tax refund on the cost of purchasing and installing solar water heating systems. With reference to the data provided in Figure 5, answer the questions that follow. All right, let's take a look in terms of the actual graph here, right? This graph is in fact showing here the number, all right, of solar water heaters, all right, basically from the year 1974 all the way down to the year 1990. All right, take a look at it. All right, when you are attempting any question for the exam and you have a graph, you have to take at least 1 to 2 minutes and look at the graph. All right, look at the parameters. Look at the x and the y axes. All right, try to determine the scale that is in fact involved for both x and y. Now, the first part of the question is describe how the tax incentive works, right, to manage the use of the natural resources, how it works, right? They're just asking a simple, generalized question. Now, a tax incentive is in fact a monetary initiative. And this initiative is in fact a method, as a matter of fact, it's a technique and a strategy, right, to try to encourage persons to be more environmentally friendly. In this regard, we are talking about solar water heaters, and in doing so, the more people they gravitate towards the receipt of this particular monetary incentive, they will actually be consuming a lot less energy because solar water heaters do in fact contribute to less emissions and less energy derived from from non-renewable resources. All right. Now, part 2, what is the average annual increase in the solar water heaters for the first 5 years after the tax incentive policy was introduced? Class, they're actually talking about the first 5 years, which is the tax incentive was introduced in 1978. Then we're talking about for 5 years after that, which is 1979, 1980, 1981, 1982, and 1983. All right. So 1978 and 5 years will actually take it to 1983. Let's see that quickly. Utilize your ruler in this particular instance here, right? We need to determine the value, all right, the average annual increase. So we're looking at the initial value and we are actually looking at the last value, especially with that particular period. If you look at the year 1983, take your ruler and you go straight across, you'll realize it is approximately 1,200 solar heaters were in fact sold, all right? For the year 1978, it was roughly at 200. All right, so that is the calculation there quickly. All right, so the period is in fact 1978 to the year 1983, right? This is a 5-year period. The average annual increase for the year 1983, right, was in fact 1,200 solar water heaters sold. For the year 1978, right, was in fact 200, all over a 5-year period. All right, so that's 1,000 divided by 5, which is in fact 200 water heaters. All right, sold on average per year. All right, so keep that in mind for me, please. And so I apologize for the untidy handwriting. All right, part three, evaluate the effectiveness of the tax incentives for changing the behavior of the country's citizens with respect to the use of the natural resource. Use of the natural resource is in fact what? The solar energy it's simply to facilitate that solar water heater. Use the actual values from figure 5 to support your answer. All right, so utilizing the actual values, the policy actually was initiated in 1978, and it was roughly 200 solar water heaters that were sold at that point in time. Prior to that, it was in fact very, very low. All right. However, beyond that, right, you would actually see a significant increase, all right, overall increase in terms of the use of solar water heaters, where the highest peak was in fact associated with the year 1989. All right. And that was roughly at 2,850 solar water heaters. That was the highest amount of solar water heaters ever sold. So technically, from the year 1978 to the year 1989, right? There was in fact a significant leap in terms of the amount of solar water heaters simply being purchased in that regard. The greatest rate of increase was associated with the year I'm saying here roughly 1987. That period from 1987 all the way to 1988. That 1 year gap, average give or take. All right. And that was responsible for the steepest rate of increase in terms of the use of solar water heaters. You could use a ruler to just check that for me as well. Okay. Beyond the period of 1989, there was a significant decline to the year 1990, where the solar water heater purchases or sales declined. All right. But generally speaking, from the period of 1970 all the way down to 1990, there was an overall increase in the actual sale in solar water heaters. So that policy was in fact very effective. To begin from 200 solar water heaters being sold in the year 1978, all the way up to an estimated 2,850, that is a magnificent leap. All right. A student wrote an examination in environmental science and gave the following incorrect answers to a number of questions on the paper. For each question, provide the correct answer and explain why the given response is incorrect. Now, the first question, B part 1. What is the difference between renewable and inexhaustible? And the answer from the student is that there is no difference between these terms. They are the same thing. That is wrong. All right. Renewable energy or renewable resources, as a matter of fact, are in fact those which can be replenished, often influenced by management initiatives, right? Whereas inexhaustible resources are those which exist in very or enormously large quantities, all right? Their rates of replenishment are extremely rapid, right? For example, we have solar energy is said to be inexhaustible, right? Because the sun has an estimated 15 billion years, roughly. Even if you want to say million, all right, that is a very, very long time. And we can utilize as much as we can within that period. So this is actually the main difference per se. Now, part 2. A question is that explain how technological factors can affect natural resource use in the Caribbean. The answer is that technological factors do affect natural resource use in the Caribbean. For example, issues such as population growth can have a big impact. As the populations increase, they require more raw materials for housing, etc., and so more resources will be used up to satisfy the growing population. Students, what the actual student mentioned here was specifically not technological factors, He spoke about demographic factors. All right. And those demographic factors, as he mentioned, population increases and whatnot. All right. He didn't touch on technological factors. Technological factors has to do with the use of machinery in terms of the exploitation and the processing and the overall extraction and use of resources. Right. Changing those resources from its immediate state, from its original ore, right, and manufacturing or producing a completely new product. What he mentioned in his answer was incorrect because he spoke about demographic factors, not technological. All right. So keep that in mind for me, please. Okay. We also have question number 6E. Part E. Is question number 6E. A student was actually overheard making the following statement. I don't understand why our teacher says that the landscape is a natural resource. You can't sell a mountain or make anything out of a beach. I don't think that our teacher is correct about this. Present two arguments in support of the teacher's comments. All right. Now, first and foremost, you have to understand, all right, that the landscape is, in fact, a natural resource. All right, as the teacher rightly indicated, primarily because of the fact that not all resources can be utilized consumptively. All right, you can utilize the landscape for non-consumptive purposes. For instance, it can be utilized for the purpose of leisure involving hiking, trekking. It can also be associated with um, nature and also photography as well. So this is in fact, the landscape can be utilized for non-consumptive purposes. All right, keep that in mind for me, please. In the second argument, I'd like to highlight first and foremost that the student indicated that you can't sell a mountain. Now, even though you cannot sell a mountain, you can actually extract resources from a mountain to which it can be sold. All right. For example, aggregate or building materials are often associated with mountains, inclusive of rocks and boulders and stuff like that, of significant value in terms of the construction industry. They can be extracted and they can simply be processed, after they are in fact sold, right, to different companies in terms of the manufacture of new products. So you cannot sell a mountain, but you can sell constituents from it. All right. In the same respect, the same mountain slopes can actually be utilized for agriculture, and the produce or the yields from that particular mountain can actually be sold, right, and given some economic value. All right. So part B now. Using an example, explain what is meant by non-consumptive use of natural resources. Now, students, from this particular example, from this particular question, you can actually see that sometimes the questions actually give you hints, even if it is after, right, or before. That is why it's always good to peruse your paper, right? Now, non-consumptive use of natural resources are in fact those which do not fall within the criteria of physically extracting or exploiting said resources. As a matter of fact, non-consumptive use of natural resources involve utilizing the resource, right, mainly for an aesthetic purpose, or even for some form of therapeutic or even research-oriented initiative. For example, hiking, right? Trekking, bird watching, ecological research, all of these can actually fall within the concept of non-consumptive use, all right, of a particular resource. Part C, give two reasons for the importance of one named natural resource, right, to a named Caribbean country. I'm going to talk about Guyana, all right? I'm going to talk about Guyana as a named Caribbean country. Guyana has forests, and Guyana also has oil and natural gas. All right. Now the importance of well, they ask us for one. Sorry, my bad. You could choose any one of those two. Ghana has a lot of resources, to be honest. All right, but if you want to choose one, let us choose natural gas, oil and natural gas. Right. One of the reasons for its importance is that oil and natural gas adds to the GDP, all right, of any given of that particular country. All right, because the processing and the extraction and the entire manufacturing industry which surround, all right, the oil and gas facility, I'm sorry, oil and gas industry, my bad. That is in fact adding to the revenue stream to that particular country. Primarily because if you are producing, you would also export, right? Significant byproducts as well. So it adds to the GDP of a country. Secondly, we have to understand that um, that particular country, which is Ghana in particular, we have to understand it also is significant in terms of providing some form of employment and some form of social stability, because once the society is employed, right, or there is a factor which contributes to the employment of the society, which is technically the oil and gas industry, obviously that can be utilized in a very positive and a meaningful way where people can benefit. They can have some form of livelihood, all right, to which society can be a little bit more stable on an economic front, or I should say socio-economic front. All right. All right, Part D. Table 4 below provides information on the forest cover of a country. We have Table 4, land area under forest cover from the year 1990 to the year 2005. This is in fact 4 years. All right. We are, well, not sorry, not 4 years, my bad. This is in fact 15 years. All right. But if you look at it carefully, you are seeing forest cover depreciating, all right, from 235,000 in 1990 to an estimated 224,000 progressively in the year 2005. Now, which 5-year period saw the greatest decline in forest cover? Now, you have to show all working. All right. Now, you can actually do this for me quickly. I'm just going to talk about it very quickly. From the year 1990 to the year 1995, there was an estimated 1,500 hectares depreciation in terms of forest cover. From 1995 to the year 2000, right, there was a depreciation from 233,500 to 226,000, which is effectively 7,500, right, hectares in terms of the actual reduction. All right. From the year 2000 to 2005, we could actually see there was only a 2,000 hectare reduction in the forest cover. So the 5-year period, you have to show the working, right? The 5-year period, which showed the greatest decline in forest cover, was in fact 1995 to the year 2000. All right, you have to show all working to get your marks. All right. Let's go through quickly. Given that the country has a total area of 512,800 hectares, what percentage of the country was under forest cover in 2005? All right, so for the year 2005, we can actually see 224,000 here, right? We could also see the division, which is total amount 512,800 multiplied by 100. You will get 43.68 whatever, which is approximately 43.7%. All right, the other part of the question now quickly, let's move on. We are simply seeing here an eco group, last question for the paper, for 2013 paper. An eco group in the country was concerned about the rate of loss of forest cover, and they believe that the government should promote natural resource conservation more actively in the country. Now, give 2 reasons to support the opinion of the eco group. Now, first and foremost, we have to acknowledge the fact that in the absence of the natural resources, which is technically referring to forests in this particular regard, we have to understand in the absence of that, biodiversity will be subjected to decline. If there is a decline in biodiversity, the ecosystem functionality will actually become less pronounced. It could be negated. All right. When that happens, folks, all right, we have to understand there is in fact a major issue and a major upset or imbalance, right, in the environment. Now, secondly, the same ecosystem services that we so require, right, inclusive of clean air, fresh, clean water, right, shelter, building materials from forest, all right, game or food from the forest and for the forested environment, even medicinal crops and stuff like that, all of these things will be affected by the recession or the destruction of the forest cover. So there is in fact need, right, for natural resource conservation. Because if it is gone, if those resources are gone, we can suffer. All right, our future productivity will be compromised. Our future generation would also be compromised. All right. Okay, so this is the last paper for this last question, sorry, for 2013 paper. All right, very quickly, we are going to go through 2014 paper, Unit 1, Module 3, particular, paper 2. All right, so Module 3, question 5A, state 2 ecological reasons and 1 ethical reason for resource conservation. Now, number 1, with respect to the ecological reasons, I'll give you the first one. We have to understand that there is, in fact, a need, all right? There is, in fact, a need to conserve resources in an attempt to ensure the functionality of the ecosystem. That is number one, the functionality of the ecosystem. Secondly, another ecological reason is that if resources are conserved, all right, biodiversity would essentially be stabilized or maintained and would not be subjected to critical decline. Now, one ethical reason, right, for resource conservation is conservation of resources will in fact be associated with provisions for future endeavors, provisions for our future uh, generation. All right, because in the absence of those resources, if we waste it today, they will suffer in the future. All right, so we need to be more considerate. All right, let's go through quickly. Now, why is slash and burn agriculture as practiced by indigenous Caribbean peoples considered a sustainable practice? Now, first and foremost, slash and burn agriculture by indigenous or native or tribal individuals, primarily in the Caribbean, are considered to be sustainable because we have to understand that their level of disturbance, right, involving fire and minor deforestation and whatnot, cutting down trees, all right, would in fact be minute. The impact would be small. All right. Unlike today, in today's world, we simply remove extensive sections of the land. But they utilize their land in such a way for cultivation only for their basic needs, only for necessity. They don't do it for the purpose of profitability. All right. And their levels of exploitation, right, are in fact not as pronounced as it is in terms of the modern world or the non-indigenous persons. All right, let's go through quickly. Now, table C, right? Part C, table 5 shows the annual amount of municipal solid waste received by a landfill in a Caribbean country. Examine the data in table 5 and answer the questions that follow. Table 5 shows the annual mass of municipal solid waste, right, by landfill site. Look at the table for me properly. We are seeing the mass for 1996 all the way down to the year 2004. But 2005 is in fact omitted. All right, we have to calculate the first part of the question is what is the total mass of solid waste sent to the landfill from 1998 to the year 2000. Right, so from 1998, they said from 1998 all the way down to the year 2000 would essentially be these values here. 176,900 plus 172,300 plus 196,200. Let's add it up quickly. Break out a calculator if you have to. When you add up all of them, you will get 545,200. All right, that is in fact the amount of solid waste that is in fact produced. Okay, yeah, that is in tons, by the way. Make sure you put your units for me, please. All right, so part 2 of the question is to estimate the annual mass of solid waste that will be sent to the landfill, all right, in the year 2005. You have to estimate that. All right, so look at this carefully, right? We have different periods. So we start at the end of 2001, so we would not be counting 2001, all right? So from 2001 to 2002, that is one period. 2002 to 2003, that's another period. 3 to 4 is one period as well, right? So these are 3 individual periods here. If you were to look at them from year to year, the maximum is 298,500. The easiest thing to do is to minus the initial value, which is in fact 207,500. It will actually be given 91,000. All right. And for these individual average, you have years. These are 3 individual years divided by 3. So 91,000 divided by 3, you will get an estimated 30,333. So if I were to add 30,333 to this end value for the year 2004, let us see what we get. You'll get an estimated 328,833 for the year 2005. An estimated 328,833 833 tons. All right, in the year 2005. All right, so part 3, state the trend highlighted in table 5 and explain how a recycling scheme might help the problem illustrated in table 5. Now, first and foremost, we have the trend, which is 133,700 at the year 1996. And we realize progressively, you realize the values actually increased, right? On a general perspective, with the exception of a few years, right? Like these two middle years here. But generally speaking, the general trend that we observe here is that there is an increase in terms of the amount of the mass of solid waste, all right, being sent to the landfill. Now, a recycling scheme, right, could actually aid in terms of this problem. It could have to remediate or reduce this effect, primarily because of the fact that you will be, in fact, be reducing the amount of clutter. All right, you would in fact be redirecting waste and harboring them in a specific environment where they can be reprocessed or reutilized, or in this case, recycled. All right. So that redirection will actually aid in waste minimization in the landfill site itself. All right. Keep that in mind. Now, part D, part 1, explain how natural resource conservation can be achieved by either land use planning, right, and zoning regulations, or sustainable yield management. All right. Now, folks, I'm going to talk about both of them. Land use planning and zoning regulation is in fact associated with specific demarcated areas, which are in fact established boundaries beyond which, right, you don't have much developmental activity, or you don't have any developmental activity. Technically, these zoning regulations and land use initiatives, land use planning initiatives, will actually provide a much more accountable approach, all right, in terms of the resources being extracted from specific areas. Zoning regulations provide a geographical boundary in terms of limiting our exploitative activities and perhaps exploration activities as well as the extraction processes. Now, that is mainly associated with industrial, all right, activities mainly for industrial as well as infrastructural development. Now, with respect to sustainable yield management is in fact associated with agricultural activities. The concept of sustainable yield involves, I should say, a very conservative methodology where you would in fact be harvesting, all right, or deriving produce from a specific area to the extent where the land or the soil itself is in fact not fully exhausted or not exhausted for that matter. So sustainable yield management is in fact a very conservative approach, all right, where produce can be derived, right, in a significant or quantified and controlled way. Okay, and it is in fact low impacting upon the environment. Because if you don't embrace sustainable yield management and you just simply exploit resources and nutrients, perhaps in a very profound monocultural activity involved, if that is happening, then obviously the resources will be depleted, which is typical of what occurred in as our food for thought, what occurred in Africa, in the Sahel region in particular, like in the mid 1950s all the way up to the 60s. All right, they were experiencing what you call a mega drought. They experienced a mega drought after that period of time. But they were indebted, and as a matter of fact, they had to highly um, cultivate certain areas, employing very unsustainable practices, and those activities contributed to nutrient depletion, which evidently resulted in the environment to be depleted greatly because of the mega drought, which contributed to soil degradation further to soil degradation rather. All right. So D part 2 now suggests three systems that the government could use to effectively achieve natural resource conservation in Caribbean countries. First and foremost, there can in fact be a significant body, right? A properly established, very unbiased, properly established in an attempt to monitor, right, and survey existing activities as it relates to resource exploitation, or sorry, resource extraction or consumption. Secondly, all right, there must be a significant legislative measure, right, that can actually be enforced. All right. Once that is the case, and the law is properly put in place and policies are properly enacted, there can in fact be a very significant foundation to which those persons who are technically in breach of said law, exceeding their resource quota for a given time period, or perhaps utilizing unsustainable practices, it can be subjected to fines and penalties. All right. Or perhaps, apart from hefty penalties, they can also be subjected to jail time as well. All right. The third point I would like to highlight is that in terms of changing the culture of society, in terms of developing and fostering a much more conservative approach, educational programs must be established. These educational programs can actually foster a unique, conservative, sustainable approach, right, among society and members of society who can actually be the ones who can have that, who can utilize resources in a sparing manner. All right. And this is, in fact, a very significant point because in many instances, if we don't have that drive, or if we don't have the mindset, if we don't have the cultural approach to become conservative, obviously resources will be depleted. Okay. All right. So question 6E, can fertile soil, a natural resource, be described as both renewable and exhaustible? Yes, it can. All right. Why? They ask us why can fertile soils be regarded as both renewable and exhaustible? The fact of the matter is that soils can be renewed primarily, can be considered to be renewable, primarily because we human beings, we can actually employ management strategies in terms of maintaining the soil structure and nutrient content. All right. And it can be replenished based upon our existing activities. It can also be considered to be exhaustible because if we don't employ such practices, the resource, which is the soils, can be degraded or depleted or washed away or greatly eroded. All right. And the fertility can be subjected to decline. Okay. Now, part B, state 1 consumptive and 2 non-consumptive uses of natural resources. All right. Now, 1 consumptive use of natural resources can in fact be associated with the extraction of minerals or perhaps the extraction of oil or natural gas from the ground. Or you could say logging, is up to you, whichever one you want to choose. All right. 2 non-consumptive uses of natural resources can be, number 1, recreational activities involving hiking or trekking, and also, right, research, which may involve, well, when I say research, I'm talking about ecological research, which may involve observation of the existing biota in the environment or the habitat itself. Okay. Now let's move on quickly. Figure 5 illustrates the average net productivity of some natural ecosystems. Study figure 5 and answer the question that follows. We are seeing the gray, well, the light gray is in fact the aquatic ecosystem, and the dark gray is in fact terrestrial ecosystems. All right. Now this is in fact the net primary productivity, which is kilojoules per square meter per year. All right. Be sure to utilize a ruler when you are executing anything or measurement or readings from this particular graph. Now, what is the total net productivity that could be achieved from the tropical rainforest and savanna ecosystems? That's for 3 marks. So tropical rainforest, as you can see, it is an estimated 38,000, that is tropical rainforest. And for savanna ecosystems, we are actually seeing here 12,000. So 38,000 plus 12,000 is in fact 50,000 kilojoules per square meter per year. All right, 50,000. 38,000 plus 12,000, which is associated with tropical rainforest and savanna ecosystems respectively. The answer will be 50,000 kilojoules per square meter per year. Part 2. Which ecosystem have the highest and the lowest average net productivity? All right, the highest average net productivity is in fact associated with I am seeing here tropical rainforest at 38,000 kilojoules per square meter per year. And the lowest is in fact associated with desert scrub, which falls roughly at an estimated 2,000 kilojoules per square meter per year. All right. Use your ruler when you're doing your measurements. Last two questions, last two parts of the question. Identify D part one now. Identify three named natural resources present in a named Caribbean country. Now, I'm going to use as Guyana. This was actually kind of pretty much a question that we mentioned earlier. Guyana has gold. Guyana has oil and natural gas, and Guyana, well, conceptualize that as another one category, and Guyana has forests. Yes. There are many other resources in Guyana, such as freshwater reserves, such as biota, all these things, right? So like I indicated earlier, if you have to indicate tree, indicate any tree you wish, you can actually indicate forests and gold and oil and natural gas. All right. If you want to separate oil and natural gas, you can do so. There's no hard and fast rule behind that, but in most instances, they are categorized under the same category. Okay, they are put in the same category. Now, part two, discuss two reasons for the importance of each of the natural resources identified in D part one above. Each reason may be used only once. So they say each. All right, so two reasons for the importance of each of the resources. All right, let us start with forests. Now, the forests associated with Guyana, all right, the first reason for its importance is that it actually is that can be used, all right, to derive building materials, right, specifically referring to lumber, all right, and it significantly contributes to the logging industry. That is one. Secondly, the forest is in fact very unique as it relates that the forest is in fact so thick that it supports a great degree of diversity, right? Plants and animals thriving in a given environment in a kind of stable ecosystem or stable habitat. And that is responsible primarily for owing to the fact that a lot of the food reserves can in fact be derived from within the forests. People go hunting, all right? People actually go fishing within the rivers, which can actually exist in the midst of the forested areas. All right, so that is one. We have two reasons here for the first natural resource. The second natural resource I'll talk about is gold. Gold can actually add to the GDP of the country because once it's extracted, it can be processed. And the produce, of course, the materials, the finished products can be sold, right? And can be a major contributor to the GDP of that particular country. That is one. Secondly, we must also bear in mind that gold can be used to make jewelry, all right? It can, apart from making jewelry, right, it can simply be used to trade or can be used as a collateral for financial transactions. Let us talk thirdly, as it relates to the third natural resource, all right? So far we did forests. What about oil and natural gas? Oil and natural gas is in fact a major component in terms of the economy of Guyana. As a matter of fact, it provides employment opportunities for a vast number of people, right? Because they have significant reserves, right, within their periphery. Also, a second reason for its importance is that this is used, oil and natural gas is used as a form of energy, right, in terms of executing certain tasks. As it relates to vehicular consumption requires, the level of vehicular consumption in Guyana is in fact related to the amount of oil and natural gas that is present there. Also, we must bear in mind, it can in fact be combusted primarily for industrial activities as well. All right, so these reasons are pretty much straightforward. All right, if they say two reasons for each, please, two reasons for each are in fact what you require. Do not go beyond, do not go less. All right, so this technically is in fact the last question for 2014 paper. All right, module 3. All right, I hope it was beneficial. Anybody have any questions, feel free to let me know. All right, I apologize for the crap for the writing and stuff like that, and for a little bit of stuttering here and there, but that's okay. Anybody have any questions, feel free to let me know. All right, you can email me or whatever the case may be. All right, students, you all keep good. Bye.